Welcome to the lesson for writing the equation from the graph of an exponential function. In this lesson, you will see two methods. The first method is the table method. In this example, we're asked to write the equation for the graph. In order to write the equation, we must know the formula of an exponential function, which is f of x is equal to a times b to the power of x. In order to write the equation, we must find a and b. A is our y-intercept. That's the point on the graph where the graph crosses the y-axis. In this example, that point's at -3. So A, or our y-intercept, is -3. To find B, which is our multiplier, we first must identify a point on the graph that's either 1 unit to the left, so at x equals -1, or 1 unit to the right, at x equals +1 of the origin. We must be careful, however, when choosing our points. We want to make sure that we can choose a point where we don't have to estimate the y value. So a point that's on the grid lines. The point that's at x equals +1 is in between y equals -1 and y equals -2. Therefore, we'd have to estimate the y value here. As a result, we don't want to use that point. So the point that we're going to use is at -1, -6. Now we're going to set up a data table. We're going to enter in the 2 points, our y-intercept, and the point that we found at -1 on the graph, into an xy data table. It's important when entering your points into the data table that you make sure that your points are in order, meaning that the point with the most negative x value goes on top, and the point with the most positive x value goes on the bottom. Once we have our data table, we can find b the same way we did when we found b using the data tables we were given in previous examples. So we need to ask ourselves, how can we get from -6 to -3? Since this is an exponential function, we really only care about multiplying and dividing, not adding and subtracting, because that's linear. I know that if I divide -6 by 2, that gives me -3. But b is our multiplier. So what I really should be concerned with is multiplying. I know that dividing by 2 is the same as multiplying by the reciprocal of 2, which is 1/2. So I can also multiply -6 by 1/2 to give me -3. That means our multiplier is 1/2. Once we have a and b, we can plug those into the formula, and that gives us the equation. So here our equation is f of x equals -3 times 1/2 to the power of x. I want to take a moment to acknowledge that some people like to use a similar method, which is called a plug-in method. And in the plug-in method, they will take the point that's at -1, -6, and plug in the x value, which is -1, the y value, which is -6 for f of x, and then plug in the value that they found for a, which is -3, and use that to solve for b. You can totally use that method, and that's a great method, especially for pre-calculus people. But it's important to note that when your x is negative, you're going to have a negative exponent, and remember that negative exponents give you reciprocals. So just be careful if you use that method with that. Before I go on to the second method, I want to give you a real quick check for b. So remember that in our case, we had our b, our multiplier, which is 1/2. And when b is less than 1, which is what we saw in our example, we have a situation of exponential decay. If our graph shows exponential decay, the graph should hook to the left of the horizontal asymptote. Remember, the horizontal asymptote is the invisible line that the graph approaches but never crosses. And in these examples, that horizontal asymptote is at y equals 0. So since our graph hooks to the left of the horizontal asymptote. It also shows exponential decay, which matches the fact that our b is less than 1. Now onto the second method. This is called the right-left method. It's actually the same thing as the table method, except for it's a bit of a shortcut because there's sort of a pattern in what we need to do in order to find b. So again, we're asked to write the equation for the graph, and you may notice this is the same as the previous example. So to find a, our y-intercept, we look on the graph and we see that the y-intercept is at -3, so a is -3. Now to find b, our multiplier, again we need to choose a point that's either 1 unit to the left or 1 unit to the right of the origin. And since this is the same as the previous example, again we're going to use the point at x equals -1 because we don't have to estimate the y value, which is at -6. Now for using the right-left method. To find b, what we can do in the right-left method is take the y value of the point that is furthest to the right, in this case it's our y-intercept, and divide it by the y value of the point that's furthest to the left. In this case it's the point at x equals -1. So we can plug in those y values, -3 over -6, to find our b, which gives us 1/2. Therefore, our multiplier is 1/2. Again, we plug those into the equation, into the formula, and we get the same equation. Let's use the right-left method in one more example. So to write the formula, we need to find a and b to plug into that equation above. We know that a is our y-intercept, and in this graph, that's at 4. So a is 4. To find b, our multiplier, again, we need to find a point that's either 1 unit to the left or right of the origin. Now, in this example, there are 2 points that we can use. We can use the point at x equals -1 or x equals +1 because in both cases we do not have to estimate the y values since those points are on the grid lines. Let's choose to use the point at x equals +1. Now we can calculate b using the formula where we take the y value of the point that's furthest to the right, in this case that's the point at x equals +1, and divide it by the y value of the point that's furthest to the left. In this case, it's the y-intercept. So that gives us 8 over 4, which is equal to 2. Our multiplier is 2. We can go ahead and now plug in a and b into the formula, and we get the equation f of x is equal to 4 times 2 to the power of x. To summarize, we need to know the formula for an exponential function when writing the equation. We need to find a, which is our y-intercept, and b, which is our multiplier. When finding b in either method, we always must choose a point that's either 1 unit to the left or right of the origin. Some people like to use the plug-in method, but remember, if you're going to use that method, be careful when x is negative. For the table method, we're going to list our points in a table, and we have to be careful to make sure we list them in the proper order. When using the right-left method, it's sort of a shortcut of the table method. We plug in the y value of the point that's furthest to the right and divide it by the y value of the point that's furthest to the left.